My name is Heather Shapiro. I'm a technical evangelist here at Microsoft. And today we're going to be talking about how to convert speech to text to sign language GIFs in Python. My translator wasn't on, but now you can, hopefully we'll go in a second, and you can see that it's live captioning my presentation. So in PowerPoint, there's a new extension that allows you to use the translator APIs, and it's just an extension, and it goes through all of your PowerPoint slides and makes a custom speech model based on what you have in your notes and what you have on the slides. So it tries to make a model that will match that. It's not always perfect. When I walk away from the mic, it gets a little iffy, but for the most part, it's pretty good. And there's also a way that you can, if English is not your language of choice, you can go to this link at the top and look at the transcripts in a different language. So, what are we going to cover today? We're going to talk about just deaf culture in general and American Sign Language and get a little intro to that. We're going to understand some Microsoft cognitive services, so specifically image recognition and Bing spell check. And then we're also going to look at how can we take a library of GIFs and get the text from them and find the most similar GIF using natural language processing. So when we think about deaf culture, it's important to know that, or to recognize that deaf people can do anything a hearing person can do except hear. So when you're referring to the deaf community or deaf culture, capital D for deaf, that means that the person is active in deaf culture. Lowercase d means that they're not active in deaf culture, but they still have profound hearing loss. Then there's hearing and hard of hearing. So these are just some terms to be aware of when you're referring to the deaf community and deaf culture. So we're going to focus specifically on American Sign Language. So there's different dialects for sign language. So there's British Sign Language, there's Chinese Sign Language, but we're going to focus on ASL. So you can all do it with me. You have A, S, L. Yay, now you all know how to say ASL in sign language. So American Sign Language is the official language used by people in the deaf culture in America. It's an actual language. It's not a shortcut of spoken English, and there's just no written form, and it's not universal because there's different dialects in different countries. The language incorporates mime and picture-like images to express and convey different ideas and concepts. So it's a lot of times what you would expect to see if you're translating from English to sign, but sometimes it's also reversed. So sometimes if you're saying something like, where's the bathroom, you might say, bathroom where instead of where's the bathroom. We're also going to take a look at some Jupyter Notebooks in Azure. Who here has worked with Jupyter Notebooks before? A few people. Who here has heard of them? Who did a challenge for the Azure Notebook Challenge? Good. I'm going to say that later, that you should all do this challenge. So Azure Notebooks is in the browser and allows you, let's see if this will work. It's Jupyter Notebooks in Azure, and it allows you to be able to run Python code without actually having Python installed on your computer, so you can do it like you would use it like you would use Jupyter Notebooks, except now you don't have to have Anaconda or anything installed. There's also a cool, nifty slideshow feature with it. So when I was looking to try to make this repository or database of sign language GIFs, there aren't many data sets out there. So Giphy actually has a channel with 2,000 GIFs from Sign with Robert. So I went through and I pulled all of these GIFs down, so about 2,000 of them. And unfortunately, the API doesn't let you pull out the tags with it. So you have to put it through OCR, or image recognition, to actually find out what is being said. So I can all say hello. So it's pretty easy to do that. It's just a REST call. I won't go through the code too much, but in our cognitive service APIs, we have a suite of 30 different APIs, so vision, speech, face detection, there's sentiment analysis, all different types of APIs there that allow you to add smarts to your applications and machine learning to your apps just through a REST call. Python, for different ones, there are different modules that you can download as well or install that you can use these cloud services as well. For this, I used the image recognition. So I put in image still that I pulled down from one of those URLs from Giphy, passed it through OCR to try to get the text back from it. And then it couldn't always get them because sometimes the shading is off, or if it's not a still, it had difficulties. So then I passed it through Bing spell check. So sometimes they would just have random letters and things showing up. And that gave me a pretty good data set. I'll show that. So pretty simple. I could just go through and say, okay, for the first 500 URLs in there, pass it through OCR, pass it through spell check, and then make a data set of the URLs and the stills. And then have a table. So at the end, you'll have a data set that looks like this. Using pandas, so you have the URL, you have the phrase, so there's like alcohol, dead, popcorn, all different phrases that you can use and try to find the most similar phrases to them. And then we have the URL and the still URLs. So what I wanted to do was try to find the closest match. How can we take this data set of phrases, and then if someone speaks or enters text, how can we find the closest match to that phrase? So there's some libraries that are in Python called, one's Fuzzy Wuzzy, and the other one is difflib, and we'll take a look at both of them. But they're different natural language processing. They're pretty basic, but it just looks for the most similar words from your phrase to what's in the data set. So I passed in all of that to the 2,000 phrases, and if I say, like, we'll see, where's the bathroom, it will pull out the closest URL. So I can say, like, what are you doing? And you can see with Fuzzy Wuzzy, it will show you, like, what are you doing is the closest. Hat, because hat is in here. Hat again. Then we see, like, what are you doing also had some, like, weird spell check things. So something that didn't get fixed with the spell check, it might not have known what it should have been, so it just ignored it. And so there's different ways that you can say some of these gifts, so that's why there's some duplicates as well. And then I was able to look at all of these and process, okay, if I say where's bathroom, pull out the GIF that matches that. Now we can see where's the bathroom. So where's the bathroom? So a common phrase that is good to know. Then if we look at difflib, we can see that we get even with the same where's bathroom, you get a slightly different GIF, so it didn't match exactly the same. And one of the things that I noticed when going through these two different libraries was that the results are slightly different. One is using Levenshtein's distance, and the other one is using a different matching algorithm. And so before, when we said, like, what are you doing? If I say, where's bathroom? It's where's bathroom is the closest match, where's the bathroom, he, her. And for different phrases, though, only he was popping up as the closest match because it was just pulling out one word from there. So going forward, trying to combine these two matching algorithms, trying to see if there's a better way we can do that, is what I would like to do going forward with that. But then there's the whole speech component, too. So I'm going to switch from Azure Notebooks to Visual Studio Code. And so similar to what the translator at the bottom is using, I tried to hit that translation API itself using a REST call. So I'm able to go in and pass, let's make this smaller. I'm able to go in, create a WAV file, and I'll show it working in a second. But I pass in a WAV file to the translator API, and then pass in all the headers and all the information. And when it gets that message, it will look to, when I speak, it will look to see, okay, can we translate it to text? And then it looks to see, does it now match some text that's in that data set? So there, you can ignore my API keys; they'll be gone they'll be gone soon. But this is all on GitHub as well. If you want to take a look at it after and play around with your own keys. But essentially, we're using like PyAudio to be able to add the speaker and record from the microphone. I don't save the file at all. I'm just passing it in through a WebSocket. So it's constantly, when I'm speaking, I have it chunked into 10 seconds that it will record what I'm saying. And then from that, it will look, you can see right here. I have that phrase, the same phrase data set that I had before. And then I'll create a little image showing out what it is. So I'm just matching, doing exactly what was broken down into those phases before, but now all in one piece. So hopefully, let's see if the gods are with me. Where's the bathroom? So got bathroom. And I can say different things. So one thing that's in there is like Groundhog Day. So Groundhog Day. Groundhog Day. So this is pulling all these different APIs together. So we used the Giphy API, which you can create a free key with, the Cognitive Service APIs for OCR, spell check, and those all have free tiers as well. And I'll pull that site up in a second so you can see. And then we're just displaying it using Pyglet, using sprites and having it loop. So putting it together, we're able to get speech to text to sign language GIFs. And the goal going forward, this is pretty like, it's not the most advanced model yet of natural language processing, but how can we pass these together? How can we parse all of the libraries or GIFs together to be able to make a sentence? Because if I say something, I don't know, what day is it? What day is it? Let's see what it comes up. So because it had what in it, or it had hat, it only picks out hat from there. So it's not the most intricate model yet, but I think going forward, this is a huge place in accessibility where we can continue to incorporate natural language processing and machine learning to be able to be more inclusive in our presentations. Because if you go to many conferences like this, there aren't always live captions. There isn't always someone signing or interpreting. So just being able to welcome a new community into the developer community that we are so accustomed to would be great. And it's kind of like a chicken and the egg because we don't know how many people actually want this, but you can't tell that until you actually offer it. So if you tell people that there are live interpreters or that it is more accessible, then people in the deaf community might come more because otherwise they wouldn't be able to they wouldn't be able to come and actually gain as much out of it if they didn't have that. And then there's also I haven't seen much data on whether or not people prefer transcripts or sign language, but if you have both, it allows just more accessible, more of an accessible nature and more people to be able to engage. Because for me, I'm more of a visual learner, so reading takes me too much time. So if I can see it and watch it happening at the same time, it's much easier for me personally. Are there any questions? I can So take a second. So if we look at some of the cognitive services that we have, if you haven't taken a look at these APIs before, there's all different types. So like I said, there's vision, speech, knowledge, and language. You can use these to create like bots if you're interested in creating bots and having natural language processing and language understanding. You can also do computer vision like this, or computer vision where you're trying to detect what's in the image, how happy or sad people are, how angry they are. You can get emotion and sentiment all from these APIs. So you don't actually have to know the machine learning aspect to it. You just have to call the API. And there are different ways that you can make them custom models. So there's a custom vision model and a custom speech model that you can add to your own applications as well. So certain things that we covered, intro to deaf culture, how to say ASL. So does everyone know it again? A-S-L. Yay. We can pull sign language GIFs through OCR, through Giphy API, and then through OCR. And then we can find the most similar GIFs for a given phrase using Fuzzy Wuzzy and difflib. And there's some other libraries as well that you can use. But if anyone is interested in collaborating on this going forward to try to combine them or find a different way to make this more accessible and how can we go forward with the project, I'm definitely open for that and love to talk with anyone. There's also all this code's on GitHub. So if you go to my GitHub, it's Heather B. Shapiro, and it is speech to sign is the repo, and it'll have all the code there. So you can, you'll just need the API keys, and I'll have to update the README of where to get those keys. But you'll be able to run this little app that I had before. Then there's also, you can read about Microsoft accessibility and what we're doing at Microsoft to be more accessible. So starting with just this PowerPoint presentation translator is a great way to be more inclusive, not only for the deaf community, but also other languages. So it can be translated into 40 different languages from my speech. Then there's cognitive services, the Giphy API. If you're interested in going deeper into the machine learning aspect, there's Azure Machine Learning or Machine Learning Workbench that you can create your own models. Then there's also Channel 9 and MVA. Feel free to email me, hshapiro@microsoft.com, or Twitter is microheather. And if you have any questions, we can take a few minutes for that. I've left a few minutes extra, but also if you're interested, I'll get to the question in a second. There's an Azure Notebook Challenge that we're doing, and if you go to this link and complete the steps, it takes maybe 5 minutes at most. You can come show us, and you'll be entered to win a Bose headset or a GoPro. So it's a pretty cool prize. But question? Yep, so on PowerPoint, it's only on Windows right now. Is that your question? Yeah, so hopefully soon it will be out on Macs, but for right now it's only a Windows plugin. But for now, I think the speech to text part took the longest. The translator API is very much in preview, so there's not a lot of documentation there, which I will now add to because I've gone through this, and it's very early stages, so that took the most time. The rest of it didn't take too long. It was more like just formatting the API calls and then figuring out PyGlyph, because I've never done that before. Going from that or TK Inter, I was like, it was a struggle, but I like this one better. So the translator API allows you to speak in any language, and it will translate it to whatever language you say. So right now I just have it saying English to English, but I could speak in Spanish and have it translate to English, and then go to the sign language gifts. It might not be as accurate just because of the translating part, but then that's why we're finding the nearest phrase or the closest phrase. So if it's slightly off, it should be okay. So if you go to github.com/Heather B. Shapiro, it will be, it's speech to sign language. Yep, and this has the IPython notebook or Jupyter notebook. It has that CSV with all of the phrases, so you don't have to actually create a Giphy API. You can just pull that CSV. And then it has the test GIF. .py is the PyGlit application, so you just have to replace the API key for the translator, and then it should work. It should. But if you have any questions, please let me know about that. And if you want to collaborate, like I said, this is definitely a passion of mine. I'm trying to learn sign language so that I can sign my presentations going forward, but I am in no way ready for that yet. So it's a passion project. Any other questions?